Download this code from codegive.com, link in the description below. Circular queue data structure, advantages, disadvantages, Stack Overflow, and code examples. This tutorial provides a comprehensive overview of the circular queue data structure, including its advantages, disadvantages, potential for stack overflow, and how to prevent it, and code examples in common programming languages. 1. Introduction to circular queues. A circular queue is a linear data structure that operates on the principle of first in, first out, FIFO, similar to a regular queue. However, unlike a standard queue, it overcomes the limitation of memory wastage associated with linear queues when elements are dequeued. In a regular queue, when elements are removed from the front, the vacant space at the beginning of the queue cannot be reused. A circular queue cleverly reuses the space by treating the queue as a circular buffer. Think of it like a continuous loop of memory locations. Key concepts asterisk front, head a pointer that indicates the index of the first element in the queue. Rear, tail a pointer that indicates the index of the last element in the queue. Capacity, size the maximum number of elements the queue can hold. Full the condition when the queue is completely filled, rear is just before front. Empty the condition when the queue contains no elements, front and rear are the same. 2. How circular queues work. Imagine a fixed size array. In a circular queue, 1. Initialization both front and rear are initially set to the same index, usually 0, indicating an empty queue. 2. Enqueue, insertion when an element is enqueued. The rear pointer is incremented, moved forward. The element is inserted at the location pointed to by the new rear. Crucially if rear reaches the end of the array, it wraps around to the beginning, index 0. This is achieved using the modulo operator, %. Rear equals, rear plus 1, % capacity. 3. Dequeued, deletion when an element is dequeued. The element at the front index is retrieved, removed. The front pointer is incremented, moved forward. Crucially if front reaches the end of the array, it wraps around to the beginning, index 0. Front equals, front plus 1, % capacity. 4. Full condition determining when the queue is full is a bit tricky because front and rear can both wrap around. A common approach is to keep one slot empty as a sentinel value. The queue is considered full when, rear plus 1, % capacity equals front. 5. Empty condition the queue is empty when front and rear point to the same index. Front equals rear. 3. Advantages of circular queues. Efficient memory utilization avoids memory wastage associated with linear queues. Vacant space created by dequeuing elements is reused, making it ideal when the number of elements is relatively constant or the enqueue/dequeue pattern leads to a lot of empty space in a standard queue. Suitable for buffering applications perfect for situations where data is produced at one rate and consumed at another, example audio/video streaming, handling interrupts, handling asynchronous tasks. The queue acts as a buffer, smoothing out variations in the production and consumption rates. Efficient implementation enqueue and dequeue operations have an average time complexity of 1, assuming the array size is known beforehand. 4. Disadvantages of circular queues. Fixed size circular queues typically have a fixed capacity, determined during initialization. If the queue becomes full, further enqueue operations will result in either overwriting existing data, if not handled correctly, or an error condition. This can be a problem if the number of elements to be stored fluctuates significantly and exceeds the initial capacity. Asterisk complexity in full/empty determination. Asterisk determining the full and empty conditions requires careful consideration of the front and rear pointers and the use of the modulo operator. Incorrectly handling these conditions can lead to errors in enqueue and dequeue operations. The sentinel value approach, leaving one slot empty, adds a slight overhead in space. Asterisk potential for overwriting data, if not handled carefully. If enqueue operations are performed on a full queue without proper error handling, data can be overwritten, leading to data loss or corruption. Proper overflow checks are crucial. Asterisk not suitable for dynamically resizing queues. Asterisk unlike dynamically linked list-based queues, circular queues are not inherently designed to be easily resized. Resizing a circular queue typically involves creating a new array, copying the elements from the old array to the new array, maintaining the order, and updating the front and rear pointers accordingly. This can be a time-consuming operation. 5. Stack overflow and circular queues, understanding the misconception. While a circular queue itself doesn't directly cause a stack overflow in the traditional sense, i.e., the call stack overflowing due to excessive recursion, the term overflow is often used informally in the context of queues to describe what happens when you try to enqueue an element into a full queue. This is technically a queue overflow, not a stack overflow. The consequences of queue overflow can be serious, but they are distinct from a stack overflow. Why queue overflow matters. Asterisk data loss. If a queue overflow is not handled, the new data might overwrite existing, unread data in the queue, leading to information loss. Program errors. Overwriting data can corrupt the state of the program and lead to unpredictable behavior, crashes, or incorrect results. Preventing queue overflow. The key to preventing queue overflow in a circular queue is to 1. Check for full condition before enqueuing. Always verify that the queue is not full before attempting to enqueue a new element. This is the most fundamental step. 2. Handle full condition gracefully. If the queue is full, you have several options. Ignore the enqueue operation. This is the simplest approach, but it can lead to data loss if you don't have a mechanism to handle the dropped data. Return an error code or throw an exception. This allows the calling code to handle the overflow situation appropriately. Implement a blocking enqueue operation. For multi-threaded scenarios, the enqueue operation waits until space becomes available in the queue. This requires careful synchronization to avoid deadlocks. Dynamically resize the queue. More complex, allocate a larger array and copy the contents of the original queue to the new, larger queue. This is generally less efficient than using a data structure designed for dynamic resizing, example a linked list-based queue. Example demonstrating a queue overflow situation and its prevention, C++. Explanation of the C++ example. 1. Circular queue class encapsulates the circular queue data structure. 2. Queue array a dynamically allocated array to store the queue elements. 3. Front, rear, capacity, size member variables to track the front, rear, capacity, and current size of the queue, respectively. 4. Is empty, and is full, methods to check the queue's status. The is full method now correctly uses the size to determine if the queue is full. 5. Enqueue, enqueues an element. Crucially, it first checks is full. If the queue is full, it throws a std overflow _error exception. This is how we prevent the queue overflow. 6. Dequeued, dequeues an element. Throws std underflow _error if the queue is empty. 7. Display, asterisk displays the queue contents, for debugging and visualization. 8 main, asterisk demonstrates the usage of the circular queue class. It enqueues elements, dequeues elements, and then deliberately attempts to enqueue into a full queue to trigger the overflow error. The try, catch block catches the std overflow _ error and handles it gracefully. Output of the C++ example asterisk. The output shows that the enqueue 80 call results in a std overflow _ error being thrown and caught, preventing data corruption. 6. Code examples in other languages: Python, Java, JavaScript. Key improvements in these examples asterisk. Asterisk error handling asterisk. Each example now includes explicit error handling to prevent queue overflow. They throw exceptions: overflower in Python, illegal state exception in Java, error in JavaScript, when you try to enqueue into a full queue, and they handle these exceptions using try, except or try, catch blocks. Asterisk size variable asterisk. The inclusion of the size variable greatly simplifies the logic for checking is full, and is empty, conditions, making the code cleaner and less prone to errors related to the modulo operator. Asterisk clarity and readability asterisk. Comments and naming conventions are used to enhance the clarity and readability of the code. Asterisk clearing dequeued elements, optional. The examples optionally set the dequeued element in the underlying array to none, Python and JavaScript, or its default value, Java. This helps with garbage collection and avoids accidental reuse of old data, although it is not strictly necessary for the circular queue to function correctly. 7. Applications of circular queues. Circular queues find extensive use in various domains. Asterisk operating systems asterisk. Asterisk CPU scheduling asterisk managing processes waiting for CPU time. Asterisk buffer management asterisk buffering data during I/O operations. Asterisk computer networks asterisk. Asterisk packet buffering asterisk storing incoming packets in network routers. Asterisk traffic management asterisk controlling the flow of network traffic. Asterisk data streaming asterisk. Asterisk audio/video streaming asterisk buffering audio and video data to ensure smooth playback. Asterisk real-time systems asterisk. Asterisk interrupt handling asterisk queuing interrupt requests for processing. Asterisk multi-threading asterisk. Asterisk task queues asterisk managing tasks to be executed by worker threads. 8. Conclusion. Circular queues are a valuable data structure for managing data in a FIFO manner while efficiently utilizing memory. Understanding their advantages, disadvantages, and the importance of proper error handling, specifically preventing queue overflow, is crucial for using them effectively in software development. By implementing and utilizing appropriate error handling, you can prevent unexpected behavior and ensure the integrity of your data. Remember that a queue overflow is distinct from a stack overflow.